Welcome to the next session of the subject Engineering Maths. We were in chapter 2 differential equations. Concept is first order, first degree differential equations. We were solving first order and first degree differential equations. The last session is ended with examples of integrating factors. The procedure to find integrating factors. We have discussed 4 different cases. Now we need to discuss examples for case 3 and case 4. Let us discuss one example to discuss case 3. Suppose the equation is like this: dy by dx plus 2y by x equal to cos x. Now this is a first order first degree differential equation, but this is not in the form mdx plus ndy equal to 0. Now let us try to convert this equation in the form mdx plus ndy equal to 0. mdx plus ndy equal to 0. So multiply this equation with the dx. So this becomes dy plus 2y by x into dx equal to cos x into dx. Now rearrange all the terms to one side. This equation will be reduced to 2y by x minus cos x into dx plus 1 dy equal to 0. Now this is m value and this is n value. So m is 2y by x minus cos x and n is 1. Now when you calculate dou m by dou y, we are getting this as 2 by x. Similarly dou n by dou x, this quantity is 0. Now dou m by dou y is 2 by x, dou n by dou x is 0. It is a constant value, so dou n by dou x is 0, dou m by dou y is 2 by x. Now both are different quantities, so this is a non-exact equation. Now let us try to find the integrating factor of this equation. Now both are different quantities. Let us find the difference of these two. Dou m by dou y minus dou n by dou x. This is 2 by x. This 2 by x we can write it as 1 into 2 by x. This 1 is nothing but n value and this is a function of x. So what is f of x? 2 by x. Therefore it belongs to case 3 of non-exact model. Now what is my f of x? This is 2 by x. Therefore my integrating factor if is e power integral f of x dx. So this is e power integral 2 by x dx. This is e power 2 log x. Therefore this is nothing but x square. So this is an integrating factor of this equation. See, in the future when you are handling problems like this, you need not do this entire calculation. You can easily identify the value of f of x. See, what is the clue to get f of x is, here the coefficient of y is 2 by x. So therefore this will be acting as f of x. So whenever you identify that the equation is in a particular form, I will discuss shortly, then f of x will be 2 by x. Therefore according to f of x equal to 2 by x, my integrating factor will be e power integral f of x dx. Therefore in this case I am getting x square. So just what I have done is, I considered this example. I tried to convert this equation in the form mdx plus ndy equal to 0. I got m equal to this and n equal to this. When I calculated these two values, dou m by dou y and dou n by dou x, I am getting different quantities. That means it is a non-exact equation. So therefore when you find the difference of these two quantities, dou m by dou y and dou n by dou x, we are getting 2 by x. This 2 by x we can write it as 1 into 2 by x. This 1 is nothing but value of n. So therefore here f of x is purely a function of x, 2 by x. Therefore my integrating factor is e power integral f of x dx. According to this rule, the result is x square. Even you can cross check very easily that x square is an integrating factor, right? Note this example. Now we discuss an example to apply integrating factor in case of method 4. Let us see what it is. Suppose if the differential equation is like this, dy by dx minus 2y by x, or this is nothing but 2 by y x equal to, for example, sin y. Now this is not in the form mdx plus ndy equal to 0. Therefore, let us try to convert this equation in the form mdx plus ndy equal to 0. Therefore, this equation is dy minus 2 by x into y into dx equal to sin y into dx. This implies minus 2x by y minus sin y into dx plus 1 dy equal to 0. Now it is in the form mdx plus ndy equal to 0. So this is m value and this is n value. N is 1. Let us calculate two partial derivatives, dou m by dou y. In this case, it is dou m by dou y is, this one is 2 by y square, and in this case dou n by dou x equal to 0. So both are different quantities. So it is a non-exact equation. I think this equation is not in the form. This is not in the form of dou m by. This is not applicable in case of case 4. Let us try to modify an example. Even you can work out this, but in this case we are getting dou m by dou y equal to 2 by y square. Dou n by dou x is 0. We are getting unpredictable result. Let us go for change of an example. So dy by dx minus 2y by x. What I do is just I will interchange the positions of x and y. So I am doing some modifications in this case. The modifications are like this. This is dx by dy. Now it works. Therefore, the equation is dx by dy minus 2x by y equal to sin y. Now therefore, let us try to convert this equation in the form mdx plus ndy equal to 0. So therefore, dx minus 2x by y into dy equal to sin y into dy. Now therefore, this is 1 dx plus minus 2x by y minus sin y into dy equal to 0. Now here what is m? M is 1 and n equal to minus 2x by y minus sin y. So here dou m by dou y equal to 0 because it is a constant expression. Dou n by dou x equal to minus 2 by y. Now both are different quantities, so it is a non-exact equation. Now let us try to find the difference of these two quantities. It is dou m by dou y minus dou n by dou x equal to 0 minus of minus 2 by y. It is 2 by y. But to get case 4, it must be in the form minus m into g of y. So what is m value? M value is 1. Therefore, this is nothing but what I will do is 2 by y, I can write it as minus 1 into minus 2 by y. Now it is minus m into g of y. So what is g of y? G of y is minus 2 divided by y. Since I don't have minus sign, introduce one minus symbol because it must be in the form minus m into g of y. So therefore, in case of this, g of y is minus 2 by y. Therefore, it belongs to case 4 of non-exact model. It belongs to case 4 of non-exact model. Therefore, integrating factor equal to e power integral g of y dy. So this equal to e power integral minus 2 by y dy. This is e power minus 2 log y, and this quantity is y power minus 2. So this is an integrating factor of this particular equation. So just like previous case, just what we have done is in the previous example we wrote dy by dx. So now I interchange the positions of x and y. Of course, I have done some manipulations in case of coefficients of x and or hs term. So previously, what is acting as f of x? Previously, coefficient of y is acting as f of x. Now coefficient of x, this will be acting as g of y. Did you understand this? In the previous case, the coefficient of y is 2 by x. In the previous example, just let us try to recall previous example. In the previous case, the coefficient of y is 2 by x and that will be acting as f of x. Now in order to get case 4, what you need to take is g of y is coefficient of this x. Therefore, this g of y is minus 2 by y, and in this case, the integrating factor is y power minus 2. Therefore, whenever the difference of two partial derivatives is minus m into g of y, then integrating factor is e power integral g of y dy. So therefore, when you want to work with case 3 and case 4, just try to identify whether it belongs to particular form or not. If it belongs to case 3, then what is my f of x? That is purely coefficient of y. In case of case 4, this is nothing but coefficient of x. G of y is coefficient of x and f of x is coefficient of y. Just reverse the positions of x and y. Therefore, in this case, it belongs to case 4. So, integrating factor is y power minus 2. Now, let me recall all the integrating factors. In case of case 1, the integrating factor is 1 by mx plus ny. In case of case 2, it is 1 by mx minus ny. In case of 3, it is e power integral f of x dx. And in case 4, it is e power integral g of y dy. That is, when you get either case 1 or case 2, the result is in terms of both x and y. In most probable cases, because the result is 1 by mx plus ny. In case of case 2, it is 1 by mx minus ny. But when you look at case 3, it is purely a function of x, e power integral f of x dx. And in case of last case, it is e power integral g of y dy. So therefore, when you are practicing questions or when you are facing competitive examinations, GATE or IES, if they ask you integrating factor of a particular equation, suppose if the options are given, right? If options are given, suppose if every option is in terms of x, definitely it belongs to case 3. Then you try to find the difference dou m by dou y and dou n by dou x. If every option is in terms of y, definitely it belongs to case 4. Again, in that case also you try to find dou m by dou y minus dou n by dou x. But suppose if there are some mixtures, so the answers are in terms of both x and y, then it may belong to either case 1 or case 2. In that case, you need to come from level by level wise. So whether it belongs to case 1 or case 2 or case 3 or case 4, right? So this is one of the important model to get integrating factors. Note this example. Now with this, we have finished all examples of finding integrating factors in all 4 cases. Now let us discuss method number 5 to solve first order and first degree differential equations. So it is method 5. Suppose I have an equation like this, dy by dx plus py equal to q. Consider an equation like this, dy by dx plus py equal to q. Such equations are called linear equations in y. Linear equations in y. Now we should know what is p and what is q. Here p comma q are either constants or functions of independent variable x only. Either constants or functions of x only. Here what is x? Here this x is nothing but independent variable. So whenever equation is in the model dy by dx plus py equal to q, where p comma q are either constants or functions of x only, then such equations are called linear equations in y. I will give an example. Suppose if the equation is like this, dy by dx plus 2 by x into y equal to, for example, cos x. Probably we have seen this example earlier. Now in this case, what is p? P equal to 2 by x, q equal to cos x. Now this is a function of x and this is a function of x. So this is called a linear equation in y. So equation must be in this form, dy by dx. It's a first order first degree equation, dy by dx plus py equal to q. So what is p? It can be either a constant or a function of x only. The same case is valid even for q also. Q is either a constant or a function of x only. In that case, the equation is called linear equation in y, right? Now, let us try to solve this equation. Suppose if I manipulate this equation like this, suppose I will try to manipulate the equation like this, dy by dx equal to q minus py. Suppose if q is a constant expression and p is a constant expression, so this is some constant k1 and this is some constant k2, then this will be purely a function of y only. Then you can cross multiply this equation like this, so dy by q minus py equal to dx. So what happened, variables have been separated, apply integration on both sides, then you will get the general solution of this equation. Now this is very clear. Suppose even if q is 0, suppose if p is some constant, for example k1, then q is 0, p is some constant k1, again this is purely a function of y only. Again you can solve this by using variable separable method. Now these two are very simple cases. If p and q both are constants, then cross multiply this equation, then variables will be separated, then you can handle this equation by using method number 1, that is variable separable method. Even if q is 0 and p is some constant k1, then this is again purely a function of y, then cross multiply this equation, then x variables will be one side, y variables will be one side, and then apply integration on both sides by adding constant c. That becomes general solution of this equation. But if both are functions of x, if q is a function of x and p is a function of x, then handling this equation is not so simple. Let us try to handle in the different way. But variable separable cannot be possible if both p and q are functions of x, right? Let us see. I will try to get the general solution of this equation. Assume that this is my equation 1. So let us try to write this equation in the form mdx plus ndy equal to 0. Therefore, in this case, the equation will be reduced to dy plus py dx equal to q dx. Therefore, this is in the form py minus q into dx plus 1 dy equal to 0. Now, what is m value? Here m is py minus q and n equal to 1. So here dou m by dou y equal to p and dou n by dou x equal to 0. Now it is a non-exact equation. You may argue with me, suppose if p is 0, what happens? See, if p is 0, that becomes an exact equation. But if p is 0, then you will not get this term, then dy by dx equal to q, then you can handle this equation by using variable separable method. So as far as my knowledge is concerned, just think that p is some non-zero constant. If you ask me if p is 0, what happens? Then you can handle this equation by separation of variables. So let us assume that p is something other than 0. Then therefore dou m by dou y and dou n by dou x both are different quantities. But when you try to find the difference of these two, so it is dou m by dou y minus dou n by dou x, it is p. Now this is nothing but 1 into f of x. Here f of x is nothing but p, that 1 is nothing but n value. This 1 is nothing but n value. So it is in the form n into f of x. Therefore this belongs to case 3 of non-exact model. So therefore what is my integrating factor? Its integrating factor is e power integral f of x dx, but this f of x is nothing but p. Therefore my integrating factor is e power integral p dx. Right. Now till this moment, what we did is, just now we got the integrating factor of this equation. Once we got integrating factor, what is our next concept? Just multiply this equation with integrating factor so that the equation becomes exact. Once it becomes exact, we know how to handle this by using method 4. Integral m dx with y constant plus integral n dy free of x equal to c. So when you follow this approach, the general solution will be like this. The general solution of this equation will be in the form y into if equal to integral q into if dx plus c. So this is the general solution of this particular equation. What is my integrating factor? This is e power integral p dx. Therefore this equation, that is called linear equation in y, belong to case 3 of non-exact model. Here we are using the term p, there we are using the concept f of x. Both are same, notations are different. Here it is p, previously it is f of x. Okay. So first or write the definition of linear equation in y, and then with this you can write this method number 5. Definition: linear equation in y. Linear equation in y. An equation of the form dy by dx. An equation of the form dy by dx plus py equal to q. An equation of the form dy by dx plus py equal to q is called a linear equation in y. Is called a linear equation in y, where p comma q are either constants or functions of x only. Where p comma q are either constants or functions of x only. Example: dy by dx plus 2 by x into y equal to cos x. P equal to 2 by x, q equal to cos x. P equal to 2 by x, q equal to cos x. You need not write this calculation. Just I have explained how to get the general solution, right? So dy by dx plus 2 by x into y equal to cos x. P is 2 by x, q equal to cos x. Next, method 5. Method 5. Subheading: solving linear equation in y. Solving linear equation in y. Consider an equation dy by dx plus py equal to q. Consider an equation dy by dx plus py equal to q. Equation 1. The general solution of equation 1, the general solution of equation 1 is given by y into if equal to integral q into if dx plus c. Y into if equal to integral q into if dx plus c. Highlight this solution. Now it is very clear how to get this general solution. Just what we have done is, we have expressed this equation in the form mdx plus ndy equal to 0. Then I calculated dou m by dou y and dou n by dou x. Both are different quantities. When I find the difference of these two partial derivatives, I am getting n times f of x. Dou m by dou y minus dou n by dou x is n times f of x. N value is 1 and f of x is p. So according to case 3, integrating factor is e power integral p dx. Once I get integrating factor, my next task is to multiply that equation with the integrating factor so that the equation becomes exact. Once it becomes exact, we have method 4 to solve it. So how to get the general solution? By using method 4, integral mdx with y as constant plus integral ndy free of x equal to c. If you apply that method number 4, finally the general solution will be in this form. This is the proof to get the general solution. This is the reason behind this. Hope you understand. This is very powerful procedure, very important model. Frequently we are getting these questions in the GATE and IES. Very frequent, very frequent, very important model, right? Next we discuss one definition, that is linear equation in X. Linear equation in X. Previous one is linear equation in Y. Now it is the linear equation in X. What is the previous equation? It is a dy by dx plus py equal to q. So here p comma q are either constants or functions of x only. So whenever the equation is like this, it is called linear in y. Now I want linear equation in x. To get this, interchange the positions of x and y so that the equation becomes dx by dy plus px equal to q. What is p? P is either a constant or function of y only. Even q also either a constant or function of y. So P comma Q are either constants, K represents constants, or functions of Y only, or functions of Y only. So therefore, in case of linear equation in Y, P comma Q are either constants or functions of X only. So in this case, P comma Q are either constants or functions of Y only. Just we are interchanging the positions of X and Y. Let me give you one example. Suppose the equation is this: dx by dy plus 2x by y equal to, for example, ln y. Now in this equation, what is my P? This is 2 by y. What is Q? This is ln y. So both are functions of y. It is in the form dx by dy plus px equal to q. P is a function of y, q is a function of y. So it is a linear equation in X. Write the definition. An equation of the form dx by dy plus px equal to q. Dx by dy plus px equal to q is called linear equation in X. Is called linear equation in X, where P comma Q are either constants or functions of Y only. Where P comma Q are either constants or functions of Y only. Note this example: dx by dy plus 2x by y equal to ln y. P is 2 by y and Q is ln y. Now let us discuss method 6 to solve first order and first degree differential equations. So it is method number 6. So it is solving linear equation in X. Solving linear equation in X. Suppose I have an equation dx by dy plus px equal to q. We call it as equation 1. Now here the general solution of this equation is same as general solution of method number 5. That is solve linear equation in y. In case of linear equation in y, the general solution is this: y into I of equal to integral q into I of dx plus c. This is the general solution of linear equation in y. This is general solution of linear equation in y. But I want general solution of linear equation in X. So in this case, just interchange the positions of y and x. Therefore, in this case, my general solution will be like this: x into I of equal to integral q into I of dy plus c. So this is the general solution of equation 1. Now what is my integrating factor? The integrating factor in this case is e power integral p dy. E power integral p dy. So in the previous case it is e power integral p dx. Now it is e power integral p dy. It is purely a function of y. That means it belongs to case 4 of non-exact model. But when you look at method number 5, it belongs to case 3. Right? Just we are interchanging the positions of y and x. So this is the general solution of this equation. And this is the general solution of linear equation in y. So in place of y, we are writing x. In place of x, we are writing y. The same case is applicable even in case of finding integrating factors. In the previous method, it is e power integral p dx. Now it is e power integral p dy. Therefore, method 5 belongs to case 3 of non-exact model. That is linear equation in y belongs to case 3 of non-exact model, and linear equation in x belongs to case 4 of non-exact model. Right? Write these points. Method 5. Solving linear equation in X. Solving linear equation in X. Consider an equation dx by dy plus px equal to q. Dx by dy plus px equal to q. Equation 1. the general solution of equation 1 is x into if equal to integral q into if dy plus c. X into if equal to integral q into if dy plus c. Highlight this and call it as equation 2. Where if equal to e power integral p dy. if equal to e power integral p dy. Note, first point, linear equation in y belongs to case 3 of non-exact model. Linear equation in y belongs to case 3 of non-exact model. Next note, linear equation in x belongs to case 4 of non-exact model. Linear equation in x belongs to case 4 of non-exact model. Right? Now, I will make you two comments, particularly on method number 5 and method number 6. That means they are related to case 3 of non-exact model and case 4 of non-exact model. Let us see what are they. When we discussed case 3 of non-exact model, I referred an example there f of x equal to 2 by x. In that case, what is my integrating factor? That is x square. So when you handle method 4, case 4, I got g of y equal to minus 2 by y. So therefore, what is my integrating factor? This is y power minus 2. So this constant is appearing as power of y and this constant is appearing as power of x. Therefore, whenever f of x equal to k by x for some constant k, then my integrating factor is x power k. So that means it belongs to case 3 of non-exact model. So whenever you have f of x equal to k by x for some constant k, then if is x power k. Similarly, whenever g of y equal to k by y for some constant k, then my integrating factor is this is y power k. Here k is some constant. Note these points. If f of x equal to k by x for some constant k, if f of x equal to k by x for some constant k, then if equal to x power k. Then if equal to x power k. Next note, if g of y equal to k by y, for some constant k, then if equal to y power k. Right? Now let me tell you a few tips how to handle integrating factors of non-exact equations and how to get the general solutions of method number 5 and method number 6. One important model in gate point of view is finding an integrating factor. As I mentioned earlier, if options are given, then what you need to do is, if every option is in terms of x, definitely it belongs to case 3. In that case, you need not verify whether it belongs to case 1 or case 2. Got it? If every option is, if option A, B, C, D, and every option is in terms of functions of x, definitely it belongs to case 3. Then you try to find dou m by dou y minus dou n by dou x. And try to represent that difference in the form of n into f of x. If the difference is n times f of x, my integrating factor is e power integral f of x dx. Right. If every option is in terms of y, then definitely it belongs to case 4 of non-exact model. Again, in that case also, you try to find dou m by dou y minus dou n by dou x. If it is minus m into g of y, before m you just get minus sign. If there is no minus symbol, introduce two minus symbols. Give one minus symbol to m and one minus symbol to g of y, because g of y contributes to the integrating factor. So in that case, my integrating factor is e power integral g of y dy. Suppose if few options contain functions of x as well as y, and few contain only x and few options contain only y, then try to verify whether it may belong to case 1. If it doesn't belong to case 1, then come to case 2. If it is not possible by case 2, then to get either case 3 or case 4, you try to find dou m by dou y minus dou n by dou x, right? Because if the result is in terms of both x and y, if the integrating factor contains both x and y terms, mostly it may belong to either case 1 or case 2. Because in case 1, integrating factor is 1 by mx plus ny. In case 2, it is 1 by mx minus ny. But in case of 3, it is purely a function of x. In case of 4, it is purely a function of y. This is one model. Suppose if the question is not related to options, if a blank question is given, then definitely a non-exact equation will have definitely an integrating factor. Question may be like this: if the integrating factor of this particular equation is, for example, mu of x comma y, then what is mu of 1 comma 2? They may ask you like this. So in that case, this is an integrating factor which involves both x and y. So in that case, definitely that equation will have exactly one integrating factor. In that case also, you need to identify the correct case, right? Suppose if you are having some difficulties, because as we know that a non-exact equation can have multiple integrating factors. So assume that I have explained only one integrating factor. Suppose if that integrating factor is not there in options, then try to verify options. Multiply non-exact equation with the first option and try to verify dou m by dou y and dou n by dou x. If both are matching, that becomes an integrating factor. Otherwise go to B, otherwise go to option C. They may give you questions in the more different way. So let me explain how the questions will be. Assume that one of the integrating factor of that equation is, for example, 1 by xy. If they ask you which of the following is an integrating factor of this equation, suppose you know that 1 by xy is an integrating factor. Unfortunately, 1 by xy does not belong to this option. Then don't feel that the options are wrong, because a non-exact equation can have multiple integrating factors. Then try to verify options. That is one way. Suppose if the question belongs to case 4, that is dou m by dou y minus dou n by dou x equal to minus m into g of y, then your answer is I of equal to e power integral g of y dy. Suppose if your calculated answer is not in any one of the options, then don't think that again the options are wrong, because a non-exact equation can have multiple integrating factors. Then again verification of options is essential factor for us, right? So these are varieties of things which we can expect from integrating factors. Another model from linear equation in Y is directly they will ask you general solutions, right? So once you identify that it belongs to method 5, find integrating factor, because in case of method number 5, f of x is important for me, that is P. If it belongs to case 6, method 6, then P is important for me. So P, in case of method 5, P is purely a function of x. In case of method 6, P is purely a function of y. Then apply suitable formula, you get the general solution within 2 minutes, maximum 2 minutes, right? Now we discuss classroom workbook, that is questions based on integrating factors and linear equation in Y, linear equation in X. Just go through classroom workbook. In classroom workbook, we have finished questions up to 14. Now let us start the classroom workbook from question number 15 onwards. Just go through classroom workbook. We start with question number 15. So they ask the integrating factor of 2 cos y plus 4x square dx, 2 cos y plus 4x square dx minus x sin y dy equal to 0. So they are asking integrating factor of this equation 2 cos y plus 4x square dx minus x sin y dy equal to 0. You can see first option is minus x. Next one is x square minus x square. All options are in terms of x. Definitely it belongs to case 3. Therefore, I will try to find difference of these two quantities. Dou m by dou y minus dou n by dou x. So dou m by dou y is minus 2 sin y minus dou n by dou x. This is n value. So here what is dou n by dou x? N is minus x sin y. If you want, you can write here m equal to 2 cos y plus 4x square and n equal to minus x sin y. So be cautious about this minus symbol. People may forget this minus. So here m is this 2 cos y plus 4x square. So m equal to 2 cos y plus 4x square. N is minus x sin y. So dou m by dou y is minus 2 sin y. Dou n by dou x is minus sin y. So therefore this is minus 2 sin y plus sin y. This is minus sin y. Now you can see here minus sin y is a part of n, but this is not a part of m. Therefore there is a chance to get this n value, but to get this n value x is required. So multiply with x and divide with x. So this is minus x into sin y into 1 by x. Now this is nothing but n into f of x. So what is f of x? 1 by x. Therefore f of x is k by x. So here this is in the form k divided by x. So integrating factor is x power 1. This is x. Therefore in this case the integrating factor is x. So option number B is true. B is right answer. Note this. Next question, which of the following is an integrating factor of cos square x into dy by dx plus y equal to cos x? Now let us discuss question number 16. Which of the following is an integrating factor of some equation? Let us see the structure of equation. It is question number 16. What is my equation? Cos square x into dy by dx plus y equal to cos x. Now let us see. Let us divide this equation with cos square x. This becomes dy by dx plus 1 by cos square x into y equal to cos x by cos square x. So therefore this is dy by dx plus secant square x into y equal to this is secant x. Now this is p value and this is q value. So it is in the form dy by dx plus py equal to q. So this equation is linear in y. Here p is required for me. So here p is secant square x. So what is my integrating factor? This is e power integral p dx. So this is e power integral secant square x dx. So therefore this is e power tan x. It's a very direct question. It belongs to method 5, linear equation in y. Just we have done division with cos square x. Therefore my equation becomes linear equation in y. P is secant square x. In fact, p is required for me to get the integrating factor, right? So once p is secant square x, my job is very simple. So therefore I of is e power integral p dx. I got e power tan x. So option A is right. Note this point. Now let us discuss question number 17. So if x cube y square is an integrating factor of the equation 6y square plus axy into dx plus 6xy plus bx square dy equal to 0. So if x cube into y square is an integrating factor of this equation, then equations are given in terms of a and b, small a, b. First option 3a minus 5b equal to 0, 3a plus 5b equal to 0, like this. So if whenever this is an integrating factor of this equation, they are asking what is the relation between constant a and constant b. Here a comma b are constants. This is very clear. So here if whenever x cube into y square is an integrating factor of this equation, then what is the relation among constant a and constant b? Let us see. Since it is an integrating factor of this equation, when you multiply this equation with this, it becomes an exact equation. Now I call this equation as 1. So this is my integrating factor if. So therefore multiply this equation with if. So 1 into if implies x cube into y square. This is 6x cube y power 4 plus a x power 4 y cube into dx plus 6x power 4 into y cube plus b x power 5 y square into dy equal to 0. This is b and this is 6. Now this is m value and this is n value. Since it is multiplied with an integrating factor, this equation becomes an exact equation. So dou m by dou y must be equal to dou n by dou x. This implies, let us try to find dou m by dou y. So dou m by dou y equal to, this is 24x cube y cube plus 3a x power 4 y square equal to dou n by dou x. So this is 24x cube y cube plus 5b x power 4 y square. Now you can see 24x cube y cube, 24x cube y cube will be cancelled on both sides. Therefore you can write 3a into x power 4 y square equal to 5b into x power 4 y square. Now therefore x power 4 y square will be cancelled on both sides. This implies 3a equal to 5b. Therefore 3a minus 5b equal to 0. 3a minus 5b equal to 0. Just we have multiplied this equation with an integrating factor. Since it is multiplied with integrating factor, the equation became exact. That means dou m by dou y and dou n by dou x will be same. So when you equate these two quantities, I am getting a relation between small a and small b, that is the 3a minus 5b equal to 0. So therefore here option A is right answer. Note this. This is the end of session. We continue class 2 workbook even in the next session also. That is questions based on integrating factors and linear equation in y and x. Thank you so much.